Hello friends, let's solve this question. This question 28 gram substance X having 65.3% oxygen, 2.04% hydrogen and 32.65% sulfur is dissolved in water and 28% weight by volume X solution is made. So find percentage weight by weight, molarity, molality, normality of the solution, mole fraction of water and substance X, number of molecules of X, number of atoms of hydrogen, sulfur and oxygen, total number of electrons, protons and neutrons in X. To find all of this concentration or all of this, we have to find the molecular formula of X. From which? From the composition. Here we have given. So 28 gram substance X dissolved in water and we got 28% weight by volume solution. So let's find the molecular formula. Suppose we have 100 gram substance X, 100 gram. Yeah, we have given 28 gram substance X in question, but suppose we have 100 gram X, means 65.3 per 3 gram will be oxygen, 2.04 gram will be hydrogen and 32.65 gram sulfur. To find the composition or molecular formula X, we have to suppose the 100 gram of X. Yes, we can also find we will get same answer when we suppose 28 gram substance X. So let's solve this question. First of all, we have supposed 100 gram substance X. So 65.3 gram will be oxygen, 2.04 gram will be hydrogen and 32.65 gram will be sulfur. Here is the gram, okay. So divide all these with its atomic weight, all these weight with atomic weight, we will get moles of the respective elements. For sulfur 32.65 divided by 32, we will get 1.02 mole, and for hydrogen 2.04 divided by 1, 2.04 mole. For oxygen 65.3 divided by 16 is equal to 4.08 mole. Then divide all this mole with the list number. The list number is 1.02. So 1.02 for oxygen, 4.08 divided by 1.02 will be equal to 4. Then for sulfur will be equal to 1. Then for hydrogen 2.04, 1.02 equal to 2. You got a simple numbers. This simple number will give you the idea of the empirical formula. How? Divide all this number with the list number 1. Means you will get same numbers like 4 divided by 1 will be equal to 1, 1 divided by 1 equal to 1 and 2 divided by 1 will be equal to 1. Means the empirical formula will be equal to the molecular formula. Why? Because the empirical formula is the formula which is the simplest formula. Like suppose here C6H12O6, it is a molecular formula. If we write the empirical formula, we can write it like this: CH2O. It is a empirical formula. But for here, When we divide with least number, we will get same number. Means empirical formula will be equal to molecular formula. So what will be the molecular formula? O is 4. Here it is the number of atoms. It shows the number of atoms. So O 4 S 1 and H2. Sorry, here 2. Okay. H2SO4. It is the molecular formula of X. So here is the molecular formula of X. Let's find out the atomic molecular weight of H2SO4. The molecular weight of H2SO4 is equal to 98 gram per mole. So to find the molarity, we have to find all the related terms. Like we have given a solute H2SO4. So for solute, we will denote it as W. For what? H2SO4 is equal to 28 gram. And we have given percentage weight by volume. It is equal to 28%. Means in 100 ml solution, 28 gram will be H2SO4. So we have also given the density. Density is for solution. So density is equal to M upon V. So density is 1.2. To find the M means W solvent upon V. V is equal to 100 ml. So we will get WS is equal to 120 gram solution. 120 gram solution. So WS is here, W is here, molecular weight is here, and volume of the solution is 100 ml. But here is the, we can denote it as W solution, because we have to find the for the solvent also. W solution. W solution. For the solvent, to find the weight of the solvent, we have to divide 120 minus 28 grams. So we will get the weight of the solvent. For what? To find the molality of the solution. So Ws is equal to 100, 120 minus 28 will be equal to 92 gram solvent, means water. So all the terms is here. So let's find the molarity, normality, molality, and all the concentration. First of all, molarity is equal to W, weight of solute, 1000, molecular weight of solute into volume of the solution. W is 28 to 1000, molecular weight is 98 into 100 ml of the solution. So the molarity will be 2.857 molar. Similarly, to find the normality, normality is equal to W 1000 upon equivalent weight upon into volume of the solution. So the equivalent weight will be equal to molecular weight upon basicity. For acid, basicity 98 by 2. Why? Because H2SO4 will give 2H plus in the solution. So 49. We can write it like W is equal to 49 gram equivalent. So 28 is the solute weight of the solute, 1000 upon 4900. So the normality will be 5.714 normal. It is the normality. Let's find out the molality. Molality will be equal to W weight of the solute 1000 molecular weight into Ws weight of the solvent. We have already find the weight of the solvent. 28 into 1000 and 98 weight of the solvent will be equal to 92. So molality will be equal to approximately 3.1 molar. So it is the molality. So to find the percentage weight by weight, we have the formula. The weight of solute, weight of solution into 100. So weight of solute is 28. Weight of the solution is 120 gram. We already find it and how in 100. So the weight percentage weight by weight will be equal to 23.33 percentage. So it is the percentage weight by weight. So let's find out the mole fraction. To find out the mole fraction, we have to find moles. First of all, NH2 is equal to 92 by 18 will be equal to moles. Here I am writing 4 numbers after point because to get the exact number, NH2SO4 will be equal to 28 upon 98.2857 moles. So total mole will be equal to 0.2857 plus 5 point, it is approximately 5.4 moles. So we know that X for I means mole fraction of I will be equal to moles of I upon total mole. So similarly for H2O, NH2O upon total mole, 5.4. So it is equal to 5.9465 and mole fraction is unitless. XH2SO4 will be equal to NH2SO4 and total mole divided by total mole. So the mole of H2SO4 will be equal to 0.2857 and 5.4. So it is equal to 0.0529. So here is the mole fraction of H2O and H2SO4. Number of molecules of H2SO4. Number of molecules of H2SO4. So we have already find the moles. Remember that 1 mole will be equal to Na 6.022 into 10 raised to 23. So for we have to only add the moles, respective moles. For X mole, so X into Na. So here the number of molecules of H2SO4, to find the molecules of H2SO4, the moles is 0.2857 and 6.022 10 raised to 23. So the answer will be 1.72 into 10 raised to 23. So the number of molecules is 1.72 into 10 raised to 23. Then we can find the number of atoms from this answer. How? For hydrogen, number of atoms will be equal to, there are two hydrogens in one molecules. In one molecules, there are two hydrogens. So in these molecules, 1.72 into 10 raised to 23, how many atoms of hydrogen? So 2 into 1.72 into 10 raised to 23 will be equal to 3.44 into 10 raised to 23. Similarly, for sulfur, 1 into 1.72 into 10 raised to 23 will be equal to 1.72 into 10 raised to 23. Similarly, for oxygen, there are 4 oxygen in one molecule. So for 1.72 into 10 raised to 23, 4 into 1.72 into 10 raised to 23 is equal to 6.188 10 raised to 23. Here is the hydrogen, here is the sulfur, here is the oxygen. Where is the number of atoms in this 28 gram substance? In 28 gram substance H2SO4. Let's find out the number of electrons, protons and neutrons. It is easy as atoms. To find these, in H2SO4, one molecule, in one molecule, how many electrons? Electrons, neutrons and protons. So for protons, in hydrogen, one hydrogen, one proton. So 2 protons for hydrogen, and for sulfur, 16 proton, and in oxygen, 32 protons, because in one oxygen there are 8 protons. So what will be the answer? 50. Similarly, proton will be equal to electron. So we can also write it as 2 plus 16 plus 32 will be equal to 50. But neutron, in hydrogen, neutron is absent. So there are 2 neutron is absent. Means the 50, we have to write it 16 plus 32. Why? Because the sulfur have same number of proton and neutron, and also oxygen have same number of proton and neutron. So 16 plus 32 will be equal to 48 neutrons. So we have got the proton, neutron and electron numbers in one molecule. So for 1.72 into 10 raised to 23 molecules, so let's find out the number of electrons. I am changing the color of 10. So in 28 gram, so 50 into 1.72 into 10 raised to 23. Similarly, neutron, 48 into 1.72 into 10 raised to 23. For proton, 50 is 1.72 into 10 raised to 23. So here 86 into 10 raised to 23. Here also 86 into 10 raised to 23. Here 82 into 10 raised to 23 in 28 gram substance. So here is the answer of the question. I hope you understand all this. Thank you.